Hey guys, wow, welcome back. Here it's Tuesday. It is April 28th on Kitchen Table Chemistry, and what we're trying to do here today is to be able to determine equilibrium concentrations and constants. And this we're going to be doing today using what are called ice tables. Now, what is an ice table? It has nothing to do with frozen water, but I stands for initial, as in initial concentration. C stands for change, as in change in concentration, and E stands for equilibrium, as in equilibrium concentration. And usually we're going to have a start concentration, the amount that we begin with. We're going to be losing X, so the amount that gets lost, and then we'll have this final concentration minus X. Our initial concentration of products are usually zero because we're not starting with anything. So we're going to be making an X amount of this, and you can kind of see that we're going to be able to do this algebraically with X's. Here is a typical question. A mixture of hydrogen and iodine was made by placing 0.2 moles of each reactant in a flask. It was determined at equilibrium that the concentration of iodine had decreased to 0.02 molarity. What is the equilibrium constant, or Kc, for the reaction? So what I want to do is find what is my K value for this reaction. That is my X. So in order to do this, we're going to need to use an ice table. So here's my reaction, and I had 0.200 of each of these. So I'm going to set up over here my ice table. Initial, change, and then finally equilibrium. I'm going to have a separate column for the hydrogen, for the iodine, and then for the two hydrogen iodide products. The initial for the hydrogen is 0.200. The initial for the iodine was 0.200. And the initial for the two hydrogen iodides is nothing because we hadn't made anything yet before we got started. So now let's just do this. The change here, this is going to be minus X. This will also be minus X. And this will be plus 2X because it is our product. So our initial concentrations are changing concentrations, which are represented by X's. And now, now we're going to go off the page and we're going to end up with our equilibrium. Now at equilibrium, it tells us in the question, if you want to flip back to the previous slide, but it tells us in the question that the concentration of the iodide had gone down to 0.020 molarity. So that was its concentration. 0.020 molarity. So that means that if I take 0.200, which is its initial concentration, minus X, that will equal 0.020 molarity. Therefore, X has to equal 0.18 molarity. All right. So now I know some things. I know that this, because X now is equal to 0.18, that this will also equal 0.020, and this will equal 2 times 0.18, which will be 0.36 molarity. And now I've got these concentrations. I've got the concentrations for both things here, as well as 0.36 here, which is for my product. So my equilibrium statement, which we're now going to write here, once I find where that silly thing is. There you are. Okay. Let's do it in yellow. Okay. So K here equals the hydrogen iodide squared over the hydrogen times the iodine concentrations. So K will equal 0.36 squared or 0.02 times 0.02. K, therefore, I have equaling 324. Remember, there's no units on it. So that is my K value here, 324, which means that it favors, a large K value favors the products. Now, if we take a look at this, our concentration here at equilibrium is 0.36, and these are 0.02 and 0.02. So yeah, our data does tend to say that. So this here is how we solve things using an ice table. This is our first look at it. I'm going to give you two examples to do with this. There is a whole lot we're going to be doing with this, and that I included the answers with the examples, so good luck with them. By the way, there will not be any new lesson on tomorrow, Wednesday, because it is called a remediation day, and I'm not supposed to send you any new material. So this will kind of be where we're going to go for the rest of the week. And I'm going to try and do this idea of ice tables with you, and I'm hoping that we can do this remotely because this is not easy. No way, no way, no how. All right, guys, take care. Bye bye. Good luck.